Let's see what the sound looks like now. Uh, alright, let me see what it looks like. Alright. I think it's better now. Just let me know if there's anything else wrong with the sound before we get started. Uh, okay. All right. Welcome to the Anchor Founder, guys. Today we'll be picking it up from where we left it yesterday. And I think yesterday we were on accounts. Uh, yeah, this was what we're working with yesterday. The structure of accounts and how everything works together when you create an account ownership, transferring ownership between accounts, and I think so that was where we stopped yesterday. We also did a little quasar program that manipulated the state of an account. See if I can bring that up. Uh, the, see some new account, then I do forward. Uh, yeah. So what we did basically yesterday was just create we created an account and we wrote to the state, so we could also see what it looks like immediately we finish writing to the state. Yeah. So once we modified the state of the account, it got created, and I think we should just even yeah. Let's see if this was the account. This one. So let's see the life cycle of this account. How the stages that I went through. Definite, yes. Okay, there should be one transaction on it. Yesterday, create the account. Yeah, so it interacted with create. Let's see if we can have detailed logs on create account. Do we? Yeah, this is a PDA that we created. It interacted with the system program and said this is the account, then this is who's paying for it, and the owner, the program owner. To system program create account, then I think inside the same instruction we are changing the owner of the account. So that's what was done inside this instruction 2000 CUs. Okay, so let's pick it up from there. You said we are going to go into see. Okay. We're going to go into we talked about ownership, deploying an account, Who owns the account? We talked about that already. Uh, okay, resizing an account. Should we could we just play about resizing an account first before we go into accounts DB. Let's see. Everybody knows how to resize an account. Not nobody. Uh, that's the instruction. So let's assume, what should we do to increase the size of this account? This account already exists, and we want to um, increase the size of the account. We could do that with, let's do this. Let me call a different function. Okay, let's do, if the account does not exist, let's just do it if. But that would be false because we already have a init here because it's creating the account. If the account, so we cannot use initialize anymore. So let's do a different function. Let's call this modify account rs. Let's copy all that's inside the initialize, put it inside the modify account, and import it in the mod rs. So let's say there's a module that's called modify account, and there is a, we're using it publicly. Modify account, we're using everything that's inside of the account. Save that. Now we should have some good errors. Okay, not yet. But yeah, modify account is now visible. So let's call this modify account. Yeah, we still have this account I. So you can import account I from account I. Yeah, it's account I. Account I. Okay. Then we can change this to, let's say, size count. So do a condition here, and this should no longer be init. Excuse me, guys. So init should be a mutable account because we expect it to be created, and the owner, no one is paying for it since it's not been created, and account to modify. So I'm trying to think of account I. Think of an example that would be good to modify the account size. I think there's an example somewhere on my. Let's see. A good example would be, okay, account to modify. So it's not in it, so we can. Okay, let's see. What would be the best way to modify this account? This initialize account. We have one in the chat. Anyone in the chat? Anyone in the chat? Uh, not yet. I'm looking at, what if we, okay, okay. Okay, I have one example in my head now. Let me I think I did something similar a while ago. Modify accounts, repositories, of the, There is one instruction. Okay, let me pull this up here. I think I worked with this a while ago. State. This Pinocchio, by the way. Was it? No, it's Anchor. It's Anchor. It's Anchor. This is, not this one. I think it was this one. Okay, load it up. At least transfer hook. We have source in the state. I think mod should be in the mod, not the module state. Then whitelist is whitelisted. Okay. The initial example was from, yeah. Okay, so let's see if this would. All right, so let's just make. I should have thought about this. Just a direct array. So let's see if we can work around that with this. The addresses is vec pub key. Yes, and now we cannot have expected at least two generic arguments. Yeah, it should be vec. It's making it make Quasar is making it difficult to to actually do what I want to do. It's it's not like I'm trying to think of Anchor, but I'm thinking of Quasar at the same time. So what I'm trying to do, I already know an effective way to do it in Quasar. But I'm trying to see what will be the best way to do that. Yeah, I think I should just show. Oh, I need that code. Well, let's see. Vec. Oh yeah, it should just be vec. Then yeah, the maximum size for this vec will be 4. So let's see if that works. And it's complaining that I think its address should be address. Uh, yeah, address is what should be. Address is equals convec or do address that new. This should be heavy. New unique. No, from string const. I'll just paste in a random address here. Let me put this address. Listen yourself into yourself. Yeah, and there should be an error. That's to vec. One thing. So what's the error now? Takes 4 arguments, but one was supplied. Okay, if you're using if you're using a growable account like this, you are going to modify what you put into set inner. So the first argument is going to be setting as taken in inner via account inner. Yeah, it's preventing me from doing that right away. I know. So let's see what can we do for it. Yeah, I know what I'll just do. I will not use set inner here. Let's just do let's just dynamically modify the his account to create dot age is just then right up allocate the values by the way, yeah. Yep. Then we'll do the same for every. So age, then can jump. Then age can jump, then address. Okay, I didn't need this much. I didn't need that much. Yeah. Yeah. Let's see if this works. Okay. Age body 16 found in integer use 16. I think you should have a from direct. I want to solve that. The address now. Attempted to take value of method, address, and type with account. Methods are immutable and cannot be assigned to that address. Why is this immutable? I see that that address that has mute. Uh, no, that will not solve it. Let me just show you what that looks like with Anchor from the example that we did. Moment, I think it's here. Let me see if there are comments. Okay, no comments. Alright, this one was okay. Yeah, this was the initial way I did it. Then when you reallocate, okay, this is what I was trying to point out essentially. You have it was previously a vec. It was a vec whitelist account was holding a vec. Your addresses was a vec previously, and what we do there was we check if a user is adding to the vec. If it's adding to the vec, we then manually get the length of that data, then the length of what you're adding to it. Excuse me a minute. Am I sneezing this day? Yeah. So the initial size of the account, the whitelist account, and account info data levels account info. Yeah. So whitelist. 1 minute. Trying to get myself here. Whitelist is this account. Then to account info, that the length of the data plus the length of the size of the whitelist is what the yeah. So basically the new account size, if you're adding the new account size is going to be an addition of the existing data length plus the new the new the size of the whitelist essentially is what you're adding to it. So then we could try to get the amount of rents required for that new data for the new account size, the total account size. Yeah. Then just do the math. The Lamport required by subtracting from the amount of Lamport that's already existing inside of the account. Then we transfer the amount. So we do transfer from whoever is paying for it to the account. So you're just paying for the account that you want to create, yeah. So once you make the transfer, then you call resize on that account. So you expand the account by whatever length you want to do. So once you expand the account, then you can now put in what you want to put here. So it says add to whitelist. So first reallocate the whitelist, then you push the address into it. So that's basically what we're doing there. For manually increasing the size of the account, then pushing to it. I'm trying to see what the best way to do that with in Pinocchio would be in Quasar, but Quasar is preventing me from from doing something that's that I might not have control over. So I cannot do set inner and I cannot okay, let's try that again. 1 minute. But we already understand what I'm trying to aim for there. What I'm aiming for actually. Then let's see if address. Oh, my bad. Address queue. Let's call it address queue. I think that's what the problem was because there's already an address on it. Address queue. Address queue. Yeah. Yeah, it's still not giving me a mutable reference to it. That's what I say. Or let's new account. Uh new account equals immutable equals immutable reference to self dot account to create. Yeah. So say you remove the reference to that. So let's see if this one works here. Account age and do new account. Let me just skip to this part. Let's see. New account, the address queue, and still I'm not having a immutable reference to that array. It's a Quasar thing, not a Pinocchio, not an anchor thing. There's a way to do it. I did this the way Quasar expects you to do it. In the previous example, I think that one was. Let me see if I can get that. So just thinking of different ways, thinking of different ways to solve a problem is what we're at now. So that was CD. I think it was inside this vault. Not this one. Uh, what's the name? Guitar vault. Guitar vault. Guitar vault. Yeah. CD. Guitar vault. So I'm looking for this. Then I will. Then I will CD source. Then instructions. Then okay. Let's. I think it's inside the initialize. Yes, cat. Initialize the RS. Let me pump this up. So what I was looking for here was admins global inner. Yeah. So the first, the way it wants you to do it is you still you're still going to pass in the structure, but you'd have to say you'd have to actually specify the lamp port by for rent. You have to specify rent details. That approach, let's see, it will work, but it's not bare metal. Exactly what I'm aiming for. It's not bare metal. Let's do 1 minute. Try to revert everything and uh it was here, it was here, it was there. I think save. Okay, yeah. So first thing we do that works. Let's get rent account also. So we have rent, import rent from this rent get quasar rent. That should be rent. It needs us to provide because we are dynamically allocating. It needs us to provide. Setting now needs us to provide the payer, the rent, uh, and the Lamport per byte and the rent threshold. You can get all of that from the rent silver. So payer is self the payer does he want it as well. Account view, okay. Payer dot so account view that will work actually. So let me just copy the rest from this part. Rent Lamport per byte, then rent this. Yeah, I know I did it previously, but I just wanted to do with the anchor way of setting so I throw an error, so do that. So this one will work. Now I have just one vector, one what's it called? Yeah, a vector of one address. This would work. But to resize it, so let me see. Let me see now if we create this account, let's see what it will look like if we create this account. Let me do great account f great account. Do I have a great account? Ah, okay, account. So now it should be great account one, account one. Ay. Okay, let me build this. Let me just deploy. Quiz are deployed. Before we get into AccountsDB, I just forgot that we did not talk about resizing accounts yesterday. So let's just quickly go over resizing accounts before we get into. That's it's a lot. It's a deep topic. It's a big topic. We cannot cover it in a single live stream, but this is like an hour long something. We still have to do uh it's building deployed. So now we have 10 kilobytes more of now more 10.3 kilobytes. So let me I think it should be the same account ID. Previous account ID was initialize librs. Yeah, same account ID. Uh, so what I want to do now is what I want to do. I want to test this. Let's call the initialize function like we did yesterday for the test. Yeah, let's see, do I start in the list of external accounts? This okay. Was it? Blah, 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 blah. I don't think it's in this thread. This history, no, not in this history. So Solana gets we are on DevNet. So let me see. It did. I'll just copy what it did last. All I need is yeah, codex. Couldn't load the resources, no problem. I think I remember we just had to put in the EMV. this env, then do quasar test to test both of them by, don't ignore this, uh not ignore this one, let's ignore the first one. Okay, you modified it actually, so let's do not ignore that. So let's just do quasar test. And previously, okay, failed. Why did it fail? Submission transfer first. Replacement block hash none. Some, yeah. Oh, okay. UI transaction error. Let's try that again. I think let's save this 1 minute. I did not save the test. Let's see. Maybe seed derivation. I don't see derivation. That's making it fail. Hmm. I should have tested it outside. Outside. I should have tested it with the harness before testing it on main on DevNet, so to see what the error actually is. But it did deploy, yeah. It did deploy. It did deploy. Let's see this. Yeah, it did deploy. Mm, you know what? Let's not. Or should we? Should we? Might not too much. Let me see if I want to debug this. I want to see this account one. Okay. Okay. I think I know the problem is. If you have a custom, this is probably going to be a custom program error zero. Let me see. Should not be another issue. You can easily fix that. Quasar error codes. Quasar lang. If a custom error, Quasar like blue shift. You can pick that from the. You can pick it from the plug. You have no Quasar, and the error must be an error file somewhere. Error, not CLI. Test error, not test error. Mm, it's not test error. Lang, yes, source error. Account not initialized. Account not initialized. Yes. So not initialized. That's basically the error. It's 000, or yeah, this is 000. This should be 001. It's a custom program error. Yeah. Okay. So account not initialized. So which account should be initialized? Oh yeah. I think because we changed this, it's in it actually. In it, payer is paying for it. Mm, No, not address. It should be. Let's do. Let's see if the fields are making it confusing. No, I need to remove this. No, let's leave it anyway. It's not doing anything. Initialize this. Hmm. So why is it saying the account is not initialized? It's not supposed to be initialized. It's not supposed to be initialized. Set inner exclamation one. Um, address key. Uh, okay, let's try again. I don't know why it's failing that one. We deploy. Let's build. Deploy. If it still fails now, we'll just get into what we're studying. AnchorDB. I said AnchorDB. AccountsDB. Studying AccountsDB. Let's see. Quiz out test. And it should still fail. Yeah, still failed. And it's still the custom error. This is the custom error. Yeah, still the custom error. I don't want to debug this right now. I don't have the time for that. But it's not something. It's not a big deal. The problem is not a big deal, I guess. Hmm. Oh, this might be the problem. I'm passing just one, a vector of one, but expect a vector of four. Set inner. Is that the problem? Hmm. I don't think that's a problem. But yeah, let's just leave that for now and get into what we actually wanted to talk about today. I think it's here. It's here. Okay. So now we understand the life cycle of an account. I don't know why I keep commenting. It's just a simple, it's a basic diagram, and I still keep commenting it. Uh, the public key, the private key interacts. The program creates the account on chain. So when you say an account is created on chain, what do we actually mean? So that's what we want to talk about today. If we can quickly go over it. So yeah, account DB, a deep dive into Solana's account DB, where where how does every validator or every node have the same information about your account? How do every validator know know that you have two lampots, or if you make a transfer of five lampots, it's every other validator can see that your balance changed. Where do they get all of that information from? So anything that has to do with an account stays inside the database of accounts. So it's actually a database of accounts. So it's, in Solana, all data is stored, what's referred to as accounts. We all know that already by now. So the way data is organized is you can just read off it while I explain. So data is stored in a key value pair kind of uh, like we do an object. So an object is like a key is a key value pair. There's a key and it's pointing to something. So that's basically how it's still stored there. And the key would be the address, basically the address of the account. Yeah, so this is public. Let me see. I can share this in the chat. Uh, is this gonna go? Okay, I can only share to YouTube chat. Let me see. Yeah, I can only share to YouTube chat. I will try to get. Let me show it here. Yeah, blog. A deep dive into Solana's account DB. That's the URL to what we're looking at. I'll still try to share it 1 minute. Let me try check now. So you can also read along. 1 minute. Mm, I will paste that here. That's in the general chat. That one is in the general chat. Then the second resource I wanted to share was the book by Prince. When we get to that, I will also share the link. Let me look for it now. But yeah, AccountsDB is a database of accounts stored by validators and used to track account data. So we use AccountsDB used to track every data that lives on your account, and that's basically how every single validator can have every single node that you're communicating with has information about your single account. So yeah, uh, it's awkward reading and explaining. I'll just try to touch this stuff one after the other. Snapshots. When a new validator starts, it must first catch up to the current state of the chain. Exactly. So once a new validator is joining the network, it needs to be able to uh, be in sync with the previous state of the blockchain. So if I made a transfer previously or whatever happened to my account, different accounts, there's like a huge number of accounts that have made transactions in the past. So how does a new validator get all of that, all of the details that you need, all the account details that you need to start operating basically? So first, takes a snapshot of the current state of the blockchain. So the full state of the blockchain, including all accounts at a specific slot. What a slot is, yeah, a slot is the okay, let's start by saying this. Slot is a measurement for identifying a full round of ah now I'm trying to explain slot in the most basic way. Okay. A slot is a number that is attached to a block. If I put it that way, it feels like I'm going around the circles. Yeah, but if you are when you are sending transactions to the network, it's executing those transactions up until a specific period of time. And once that time is complete, yeah, once it's done building all those transactions, it sends it to all the other validators and they vote if they want that all those transactions to be included in the next block. So transactions are processed in batches, in blocks. So that's what a slot is. So one slot, then the next slot, and the next slot, and the next slot, the block, the next block, the next block. That's how basic. That's the most basic way I can explain what a slot is. Yeah. So all the accounts for a specific slot. If you go to the Explorer now, let's see. So scan. It show you we are currently on slot height 483 blah 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 block height blah 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 blah. And yeah, so this was the slot 48 30 seconds ago. The slot was 483503623. That was that slot. And inside that block, the slot is the number. Inside that block, these are the transactions that were included. You can see all the transactions that were included inside that particular block, 3 pages. Let me do 50 per page. It says 50 per page, 40 per page. So for that particular block, this were the number of transactions that were included. A total of 34 transactions were included for that particular block. Yeah. So that is this slot number here. That's what that slot is. So let's get back to the story. And there's a website that you can get to see how validators are, what whose validators turn it is currently, to be the leader of to be the one making a block. So if you reload on this page, it's validators.app basically. That's the link. Come over here, you see which validator is making a block at the moment. So it's rotating. It's a random uh it's randomly fixed, randomly assigned before it begins. So you know whose turn it will be after Coinbase is Kraken's turn, then Ilias. So you know all this beforehand. So if you are a validator and you have enough stake, I'm not going to that today, but if you have enough stake, you'll be included to be able to create blocks and propose to other people. So this is a map of all the validators that we all the voting validators that we currently have. This all the leaders that could be rotated by. So there are 100 validators in this data center. In this data center, there's just one validator. So blue shift on now, block logic. There are different validators that could get to be their turn to be the leader. So it keeps rotating based on the stake that they have. And in, I can see it at different part of the world. Yeah. So when a new validator wants to be part of the network, I wants to join and become that creates block that creates blocks, it needs to be able to know what the current state of the network is, what has been done so far, and for that particular slot, what's happening currently for that particular slot, the whole thing that happened in that particular slot. That's what this was trying to explain. Yeah, so it gets a snapshot, which is uh, the full state of the blockchain, including all accounts at a specific slot. We explain. You are requested to download. You are requested. Okay, the slots snapshot is you making a request or downloading the state of the blockchain from existing validators in the network, and you use that to create your own to bootstrap that new validator instead of starting from Genesis. Genesis is like the inception of um of the blockchain. You can still get all of that later, but to be up to speed with the snapshot, current snapshot. And so the snapshot contains two main components. It feels awkward enough of this. But on what's it called, the next live stream, I'll probably not read off of it. I'll take notes, and that would be easier for me to maybe make a slide or something. There's a lot to dig into here, so I'll just try to go over it one at a time. And eventually, at the end of all of this, we'll be able to monitor the eBPF. You'll be able to see when the state of a transaction, the state of an account get modified. Hopefully, we're able to do that. The previous eBPF project I did was to monitor when transactions are sent, monitor proof of history (POH). But now I want to monitor AccountsDB, and yeah. So this is the code. So a snapshot contains two major components. That's a metadata file and an accounts folder, which contains files that hold the account data. The metadata file is contains information about the latest block and the state of the database. Then the next one is an accounts folder that contains the files of each account. So it's like a snapshot of what it looks like. Oh, yeah, it's like snapshot. Let's take two snapshots. We have this the block, then the accounts DB metadata, and these are the account files. This is file 2062643. Those are files. The file is basically an account, yeah. So an account file. And this is snapshot. So you get the snapshot in a zip file. Yeah, okay, that's it. Yeah. Snapshot are built and downloaded as a tar archive compressed with the standard tar.zsc, and you unzip it, so you uncompress it or unarchive it into the layout as shown. Once we get some of this information out, some of the basics out here, we'll look into the code part of it to try to map out what's actually going on there. Account files. Uh, each file is of the account as by yeah, just this basic. Okay. One of the main components in a snapshot is the account files, which contains all the data for a specific slot. All the data for a specific slot. All the account data for that specific slot. So each file is organized as a list of the accounts as bytes. Blah, 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 append vect. Okay. He said in the Rust implementation, the files that contains the account are referred to as append vecs. But the name is outdated since appending is no longer used in the code base. So we refer to them as account files in this post. To get more context on this, let me pull up this material 1 minute. Mm, where is it? Where you at? Where you at? Uh, let me close this so I do not choke my PC. 1 minute. I'm trying to bring up the material. I think it's open somewhere. I was gonna share this material also yesterday. I think I forgot. Yeah, Prince's book. This one. So let's just get to it here. Is this what I was trying to explain? Is this what I was trying to explain? Sorry. Yeah. With Solana's sea level and proof of history, what I monitored. Okay. Most of these attack vectors were substantially neutralized. This is just by the way, except for a very important one. That's one thing that was still a problem. State bloat. Problem is more obvious in Solana because as a natural consequence of Solana's high speed, it generates so much data at a faster rate than Ethereum, making state bloat a more immediate and pressing concern. So if you are generating more data, if you have more accounts, if you're writing to accounts faster, that means you have bigger states quickly. You quickly have bigger states of the side of accounts or whatever you're storing. Yeah. So it's a problem. It was a problem. So that's what this is trying to say. So this name is however outdated since appending is no longer used in the code base. So they switched from appending to they fix that problem. So appending just means you're adding something to the end of the list. So an append only vector. So let's see what it says here now. The problem of state bloat is quite evinced from its phrasing. Means it's obvious state bloat bigger you just have keep having bigger chunks of data. It involves the process of the validator hard drive constantly filling up with new data and never deleting the old. Yeah. And as more applications are built and more users make transactions, the amount of data a new computer needs to download and process to participate in the network grows substantially. So if a new validator is going to join the network, you need to download all this data to be able to participate in the network. Okay. She says the problem is not about the history of all transactions. No, it's about the current state that is up to the minute balances of all accounts and all data stored in every program. So now I see what we're talking about here. Yeah, so now let's get back to let me see. This is the PDF. I think it was let me get it from his website, Prince website. Engineering Solana, engineering Solana, Prince. If Twitter brings it up, a problem. Twitter doesn't bring it up, problem. Yeah, we have it. Arsenic and generation and cool. Yeah. So this is the book. Read now. If you click read now, you get this book. Yeah. So, but let me give you the full link to the whole thing. Yeah. So I just copy this and send it over in the chat. Also, 1 minute. Uh, yeah, we get it. Uh, okay, found it. Now share in the chat. I'll share in the chat also. Yeah, I shared it in the chat. Sorry, I shared it. I shared it in the chat right now on X, and let me post it also on the YouTube chat. Yeah. Okay. Good. Show this. Yeah, this one. So it's a robust book. It covers a lot of things. The SVM, accounts DB, what we're talking about, TPU, consensus, and voting. I think it's top year for things that the book covers. So I'm using the book for getting familiar with everything agave, everything Solana, basically, everything validator, mechanics, CPU, the TVU. Let's just go to the content of the book here. So you can see page 90, page 90. So you can see what I'm talking about. Talks about how Solana works under the hood, the SVM, RABPF. I say talks about accounts DB, talks about TPU, it talks about uh, different tooling, benchmarking. Yeah, I think we did this in turbine quotes. This particular and this resource was actually recommended for turbine quotes too. So it's a great book overall. There's lots that one doesn't know about Solana and just need to get up to speed. Okay, 90. All right, so back to accounts DB. So account files. Then we do the data. Okay, we just know what all of these are not uh directly. You could just read all of this up. Right, to trying to quickly skim up. So it says, okay, this is what the account file format looks like. There's the account header and the account header data, the account data basically, sorry. The account header and the account data, there's padding, account data, padding, account header, account data, then account garbage. Account garbage is for when you zero out the state of an account. Let's say you close the account here, so all the state is zero. So what happens to the account is now garbage. That's now garbage data. So something would happen to it at a specific time. To clean up will be done to it. But yeah, we'll get into that. Accounts in file, so extract, write version, obsolete, data length, pub key, lamport. Wait. So we talked about what the component of an account yesterday. Yeah, talked about it keeps track of the lamport, parent epoch, then the owner of the account. The owner of the account, is it executable, and what data is inside the account. And here also, write version obsolete is actually obsolete. And data length, the total length of data. This is important because let's just keep reading. It's highlighted also, so I don't want to repeat it. Uh, yeah, exactly. Since an account's data is a variable length array, what does that mean? An account has a maximum size, yeah, but how do we know the particular length of the accounts? All these accounts are stacked beside each other. Everything is just bytes, yeah. Everything is just a big blob of bytes. And we have a tool or an interface to read meaningful data from that big blob of bytes. So how do we know where to start reading from and the end of the account. So let's assume uh let's assume all the accounts are something like this. You have UH, 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 UH. I will increase size of it. So let's assume for a minute now that this is what accounts. This is how accounts are stored, just bytes. Yeah. So how do we know that this is the end of one account or this is the beginning of another account? But since everything are just stacked beside each other, we know by utilizing the header. So that header tells us this particular account. See, yeah, the account header and the account data. So this particular account, this is what it looks like. So the account is telling us this account has a data length of whatever length it is. This is the pub key, lamp port. Okay, this is not even this is not even what I want to use explain this with. It is in it's in I think it's account index. The account index. Let me get there. Let me get ahead of myself. I'm trying to explain it, but I think it's down. You just have to get to it. When we get to it, I'll explain it better. Okay, so since all account data is variable length, we first need to read the data length variable. So we know how many bytes to read in the data field. Exactly. So in the diagram, the account header stores useful metadata about the account, including the data length, and the data contains the actual byte. So this header tells us how to read a particular account, and the data is what is containing the actual the data. What I'm saying, the account data is the actual data that's inside the account, and the header is telling us this is how to read this info. This is how to read this data. It's just like packets in networking. If you're sending a packet, there's going to be a header file, a header attached to the packet. So the header tells us what's the size of this packet, where we're sending from, what the destination is. So that's basically what this is also doing. So this is an header that it gives us information about what the next data is going to be. So you can read it appropriately. Since everything are just stacked beside each other, I need to have a an indicator to help you point. Yeah, pseudocode. So this is a pseudocode that passes all accounts from a file. So let's see. Let's have a look at it. Let me bring this down. Mmap file is just a big blob of bytes. Initial offset is 0. This is pseudocode, by the way. This is not real code. It's just how you should think about it. The static values is this is the static values. This is how we talked about here. Yeah, accounting file. So these are the I see that's the header or the indicator of the account. So data length, pub key, lamp port, rental watch, everything I need to know about the account. So for all the accounts, while it's true, we want to know what the what's the size of this header. So the size of an header would be this is for that's 8 plus 8 plus 32 plus 8 plus whatever size of an airport is plus 32 plus 1. That would be that this one is not this is not variable. This doesn't change. This is what the size of an header is. So the header is always predictable. It's always predictable. So we need to know the size of an header first. Then we know we cast from the we're reading from offset 0 here initially. Initially we are at offset 0. So mmap file cast okay in the cast. So the mmap file from 0 to 0 plus the size of the header, then read it as a static value type. This is just pointer manipulation. Let me see if I can do let me see if I can write a simple code for it. Is it necessary? Is it not? Yeah, let's why not? Let's go to Rust's books. Yeah, Rust Playground. Rust Playground. Uh, well, let's talk about, yeah. Okay, this was byte shifting. Yeah, I was doing byte shifting there. Right. Let's say we have a data. Let's just say let's some data is a byte array of uh byte array of 20. Some data is U8, U8, 10. Let's say it's just 10 bytes, yeah? Or let's just say 5 bytes for clarity's sake. Let's just do 5 bytes. 5 bytes, I'll put 20, let's put 10, let's put 4, let's put 5, 6, 1, 2, 3, 4, 5. So that's 5 bytes, yeah? This is just bytes. But what if this could be casted into something meaningful, something more meaningful? So let me just do, let's, let's go outside here. Okay. Struct some 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 something something is this, and we have first is a u60, sorry, u16, that's 2 bytes. And second is a, what about that, is a u8. Then is 3. Third is a u, let's see, that's 2, 4, 6, 7. So let's make it 7 bytes. Let's see, 7 bytes. This is 4 bytes. This is 1 byte. This is 2 bytes. That's 4, 5, 7. Let's do U8. Let's pack it with U8 so it's consistent. And this would probably throw an error. Let's see. We don't know. And yeah, so we can now say this is like some arbitrary data. So could we cast this into something? We could. And could we read this as something? Yeah, we could. So if there's an implementation something, let's just do this length. Well, you know what length is. Pub const len is a u64 y whatever, and that would be choose std. But I need Rust formatter up here. Let me bring this out here, and I'll just create a new Rust project and paste that in because I need Rust formatters help. Uh, Close this. Dot T. cd documents, list that out, then do cd, just make directory playground, cd playground, and cargo new custom. There's no, oh sorry, custom code, custom. Let's open this. Why not? Uh, and bring this up also. So inside source, we have main file. Then let's pour all of that here, so we can have help from Rust Analyzer. Um, Save this. So let's use core. I think it's core. I think there's a size of. Let me see. Size of is from core mem. Yeah, exactly. Core memory and size of size of something. And this should be a total 64 found this size as U64. Okay, that's a question. No question. So we have this is the length of something, and it should be throwing an error. Attribute should be applied to an enum. Sorry, you uh, let's just see. Oh, that's big. Yeah, what's the size of this? Length should be 8. Yeah, because it added padding to it. This is 2 plus 4, 6 plus 1, 7. Let me see if I arrange this as 8. Uh, uh, Padding equals you 8 1. Uh, see, it used to be 8 or to be 9, 12. I need to, okay, let me make this. Let's just do U8 to, I don't want to start bothering about around with padding. U8 4. So this is, we know this is a U32, should be, and this is a U16. Yeah, so if I remove this, we should have tightly packed 7. Yeah, now we have 7 as the size. So if I do call mem, this should be length should be 7. All right, so we are good there. And now we have 7 also. Yeah. Uh, so I was trying to cast this as you implement something. Let's set the constant. Yeah, not used. Okay. Yeah. Then what else I want to do? Okay, let's see if I can cast this. Let's okay. So let's do uh fn cast from is a it's taking in bytes. Self, no, not self, because it's not actually. Yeah, let's do self. Why not? Self then takes in bytes as U87. Then it should return a something. Return self. Yeah. So essentially, it should just do. I can just manually unroll it basically. So we do. Uh, I can found. Okay, yeah. So I could just do. Wait, let me see. I can just hold on. First trial is type of bytes, but it's now uh, Is that it's wrong? Sorry, permit. Just reference this. I know. I'll return self. 1 minute. I'll be referenced. It's byte. So let me do. Hmm. This cost. Okay. As let me do unsafe. As self. Uh, uh, let's see. Let's see if I can return this. Then this should be unsafe as costs. Let me just quickly fix this shit. Mm, that is special something from non-productive cars, and then let's see. Ah, let's throw it in the thread. Just something simple as good as thread. Fix the typing. Could not extension could not resources. Okay. J Rex fix the casting. Uh, not now. Fix the casting. What's it? Fix the casting here. And it was something very simple that needs to be there. Uh, uh, I think that's cons U8 as self. But let's see. Just use direct casting. I don't want to. But no problem. It doesn't want to do it. It wants to spell it out explicitly. So let's just do that instead. I didn't want to do this. Let me see if I can poke it to do that. Can it be done with pointer casting unsafe? I don't want to manually do this, but I do that. Yeah, oh, I should have collected this as a pointer first, then as const self. Uh, Process can cast a pointer but cannot cast that pointer directly into struct value for this. 7 bytes alignment is one, so it works. So the alignment also safe. Yeah, yeah, do that. This is stupid because I would have just done that myself. Okay, yeah. So now I think it has done that. So now I can do. Can I cast some data from okay. So demo to cast some data into a something type. I could start typing it, but now this is making me lazy. So let's let it do it. Uh, what are you trying to say? One demonstration, something. I was trying to say. Yeah, yeah. So this is what I was looking at. Let's new. So if we have this fail to save, overwrite new, it was writing something to it. I don't have time for it to finish. So it is not debug, so we need to implement debug. uh, drive, debug. If you want to copy, clone, copy. So yeah, this is what I was trying to. This is something similar to what it would do. So essentially, we have just all data, all accounts as this, but we have a pointer, a system that helps us cast. So we can cast whatever data is inside the accounts file. Whatever data is inside the accounts file, we can cast it into something. But in our case, something would be an account. So whatever type an account is, you do that. Yeah, that's basically what I was aiming for. Let me run this and see what is printed. So yeah, but now, so essentially that's we had to go through all of this just to demo that. Apologies. Hmm, let's get back to reading. All right. So I had to go through all of that to demonstrate what was happening here. So we cast the offsets and this whole static value. We cast whatever is inside the file from bytes 0 to, we are starting at offset 0, right? So offset 0 to the end of the size, we know the size. Then we cast it into a static value type. So we receive it as a static value type. Something similar to this. We have we have the existing data somewhere. So we cast it into something. But now if we have more, let's say this is 10, 20, and we just have more data. So we can now say cast from should be, it's also taking size, because this is going to be size 7, yeah? Something can only be size 7. Now we start reading from index, whatever to 7. So that's it. So you can start casting if there's a valid account from this index to the seventh index. You start reading from this index to the end of it. But for example, we just did something straightforward with where we knew that both data are of the same size, but in the account file they have different sizes. So you only want to cast out, not to cast what you are looking for, essentially. Yeah. So we got this part done. We return it as a static value. Then read the data, then append the data as static value and data. So that's basically what this one is doing. Just a mental walkthrough of how it works. Then the account index. Now that we understand how account files are organized to store accounts data, we also need to organize this data by the account public key. Aha. So we need to build a map to the map that takes the word address or the address and points it to all the data of the address. That's what this is doing. If you scroll down, you see here there's a map which is taking a pub key and pointing it to a vector of file ID and offset. Okay, let's start from here. This mapping is also referred to as the account index. So, more specifically, we need a mapping from a pub key to a tuple of file ID and offset, where file ID is the name of an account file to read. I think it's something like this, name of an account file to read, and and the offset. So where are we reading from? We know there's an account file. So where is this account? Where is the account we're trying to read? Where is it located at? So that's the offset. How many bytes of where we're starting off reading? Is the index of the account bytes in the file. With this mapping, we can access the associated account of a pub key by opening the file associated with the file ID and reading the bytes starting at offset. So an account can also change across slots. Yeah, it will definitely also if your account is involved in a transaction, the state of the account will change across different slots. So a snapshot might include multiple versions of the same account across different slots. Definitely, that's why it's a blockchain. So to associate each account pub key with a collection of multiple file locations in Agave, there will always only be a single account file per slot. This means we can structure the account index as a map of pub key. Let me see. I think they have chats coming in. My mic working. Okay, we're good. So we're good. Yeah, this time we're good. Okay. Sorry, I was trying to make sure we're on the same page. Okay. Vec file ID, which maps from the pub key to a collection of account references. To read the latest state of an account, we would also need to find the reference with the IS slot so we can also track the slot associated with each file ID. That doesn't ring a bell yet, but let's keep going. So this is like an account index. That's the hash map of the pub key. Then, yeah, sorry. The slots, that's the IS slot from the most recent version. The file ID, yeah, this file ID. Excuse me. So this is the file ID. Inside this file, there are different accounts. So we want to read at a particular offset. So this offset is where we are sure that an account exists at this offset. So it's a vec of at this particular slot, that's the IS slot. So that must be the current slot. Open this file ID and the account that we want to read is at this offset. So that means if I have a pub key currently, my wallet address, inside the hash map, inside the account index, it will take my wallet address, then point it at a vector of at the current slot. This is where my wallet address exists inside this file. It exists inside this file, and inside that file, it exists inside offsets, whatever, maybe offset 2000 or offset whatever offset is. But there are a lot of accounts inside this file at that slot. You understand? So it makes the mental model more interesting that way. So you're not thinking about an account every time you are trying to make an instruction. So you just having a reference to where that account lives inside the validator. Yeah, it's starting to make sense. It's starting to be interesting now. Because there are so many accounts on Solana, the index can become very large, which may lead to RAM requirements. So large RAM requirements. To reduce this requirement, Solana utilizes a disk-based hash map. A disk-based hash map. Okay. So account references are default stored on the disk. When the pub key is accessed and read from disk, its account reference is cached in the RAM-based hash map for faster access later. So if I read from an account now, it puts that account on RAM in case I want to read from it. A second time will write to it. So when reading accounts for a given pub key, the general flow will be this. Check the RAM first. If the pub key is not there, check the disk-based index. If it's not there, then the account does not exist. For that example that we showed yesterday, I said account not found. They check the RAM, then they check the disk-based index of the validator. Then if it doesn't find it, it throws an account not exists. Account does not exist error. Reading an account. If we want to read data from a specific account and we know the account's pub key, we find this location in the account file by looking up its pub key in the account index. So this is the pub key. We find this location in the account file by looking up its account by looking it up in the account index. So that's basically what I'm saying. By looking up its pub key in the account index, we'll pick the account reference from the most recent slot. That's the most recent slot. And then read the data from that location in the account file. This data can be directly interpreted by the validator as an account structure, yeah, to return it as an account structure. So just basically explaining what an account would be and what writing to an account would be. For example, when write up processing block fractions, blah, blah, blah. The two main steps for writing this account include writing the account data into a new account file associated with the slot, and updating the index to point to the location of this new account, i.e., append a new slot file ID and offset item for each account in the file. This is okay. Let's try to read it more slowly. Another key component of AccountsDB is tracking new account state. So when there's a new there's a modification to an account, we need to also know where what the modification is. So instead of overwriting, you can't even overwrite since it's just an append only vector. You leave that as it is, open a new file. So for example, when a validator processes a new block of transactions, the result is a batch of new account states at a specific slot. These new states then need to be written to the database. The two main steps for writing this account include writing the account data into new account file. So there will be a new account file for that particular slot, and update the index to point to the location of this new account, i.e. append a new slot file ID and offset for each account in the file. Makes sense? I think so. Background threads. As new account states are written to the database, we must ensure memory is used efficiently by performing four key tasks. And the key tasks are flushing, cleaning, shrinking, and purging. We let's just try to. I don't want to rush it now. So let's try to see so far what we've talked about, and we map it out in the Agave code base. Let's open the Agave repo. This is Agave 4.4 cargo.toml Agave 4.2 alpha 0. So that was the pre-release version. Okay, so this is inside Agave, like I shared yesterday, there's the AccountsDB folder. I just go to answer Agave to clone the repo. Press that. You could literally search here, say answer Agave, and it takes you up to the the AccountsDB, but you may want a previous release 4.2 alpha. 4.2 alpha is the one we're working with, and this repo 4.2 alpha, 4.2, 4.3 alpha, 4.2 alpha. To be some, if you just keep going, like let's just go there. You go to the next page, you should see 4.1 beta. Okay, previous should be good. 4.2 beta, 4.3, 4.2 beta. I think that version was not released publicly, so it's not made a release as a release. So it's just 4.2 release candidates. So the alpha was really bugged off or something. But yeah, and this article was from 2024. So you want something that does not change a lot since then. With what you're reading. So yeah, I used Codex to map out uh I used Codex to map out the article to the Agave AccountsDB folder. So I can be able to go through it one step at a time. And what we're talking about will be directly mapped to a file because it's a very big repo. Even the AccountsDB component alone is big. The AccountsDB, if you open AccountsDB, you would see store histogram, you see store tool. Store histogram also it's its own library. It's also a library. If you open source on AccountsDB, see account storage, see AccountsDB, account index, append vec, rolling bit field, a lot of files. So the one that's open currently is this accountsdb.rs here. And yeah, we it's a lot. It's a lot. But let's go to this line 871 first. Let's see. 871. That's the this is an account DB struct, an instance of account DB. So it shows account index. Yeah, we know what an account index is from what we explained. Let me check account index. It is an account index of an account info and an account info. What's an account index? Uh, disk value, index value, account map, program ID index, PR document index, PR document index. All right, one step at a time. We actually need to have someone on the call if any one of the contributors are free to go through this together to make the most sense out of it. But yeah, let's try to do our best. For then, I think we saw right version. Then we saw a deprecated right version. Accounts cache. We've not talked about accounts cache yet. The okay, 1 minute. Let me come to accounts DB here. Then accounts DB config. So an account DB config is a configuration for starts for accounts DB. So there's account DB config for testing, account DB config for benchmark, but the the original account DB struct is takes in an index, and account index is also optional. So account index config brings ages to stay in cache. Trying to see anything similar to what we read in the article. Not here. Should be. So let's get back into accounts DB. The rest this one. Good account stats. Good accounts. Shrink accounts. 30 accounts. Yeah. It's a lot. It's really a lot. Let's start from the top. And but it's interesting though. If you would like to spend within it. So this one is write cache limits by default. When okay, we'll flush it. Okay, we've not gotten to flush. It's still it's still on the list here, flushing. But let's see so far what we've talked about. If we can pinpoint it here. Shrink collect, scan account storage, alive accounts for particular slots, accounts bytes, shrink collect. Okay, let me see account files. Let account files. The slots that's alive for let's see. Okay, account file. This one. Append vec. Okay, it's similar. Account file is an append vec of an append vec. An append vec is where the path where the data is stored, the file that back the storage. So maybe this is like a lock, a read write state locker. If you are writing or if you are reading, okay, yeah, read only or writable. Yeah, that's evident, that's obvious. Then okay. I think this is interesting. So when we're done with the account append vec, it drops, and what it does is if it's dirty, stop indexing or something. Uh, all right, so there's just a lot to go into here, and it's more interesting now that we're even looking at the code. So we can put a pin on it here, and we'll pick it up to maybe tomorrow. Tomorrow we can do tomorrow, or we do yeah, tomorrow is fine. Why not? All right, so let's just take a breather, then go over everything I've talked about today, and tomorrow we keep until you understand of the repo, and we try to monitor it with eBPF. That's the official aim, the original aim of this series. So, guys, this has been the Alpha Founder. It's an interesting session today. I think everything good on the audio compared to yesterday. There was a buzzing sound from yesterday, but I hope it's fine now. Yeah, guys. So, thanks for tuning in. This has been the Alpha Founder.